Let us understand how to solve quadratic inequalities algebraically. We have 4 different questions here. I'll do 2 of them and leave C and D for you to do. Now, part A and B, we have quadratic equation parent group x squared, which is less than 9, and then we have x squared greater than equal to 1. The idea is to understand that when in quadratic inequalities we have less than sign, then what kind of result are we expecting? And when we have greater than equal to sign, what kind of result do we get, right? So that's the whole idea. So keep a focus on that, and then we'll move on and do similar questions. So let's start with x squared less than 9. So to understand it, let me just graph it, right? So we have because the parent function, let's graph x squared first. So x squared is a graph which is a parabola with vertex at the origin, right? When we say that x squared is less than 9, it really means that if I draw a line y equals to 9, let's say this is my line, which is y equals to 9, then the solution is wherever x squared is less than 9, that means this portion. Do you see? That means this portion. That is the solution. Now how do we get that solution? To get this solution, we need to find the points of intersection between the graph of x squared and 9. Once we find these points, then we know that that is the solution. In between, do you get the point? So the strategy here is calculate what is x squared equals to 9, right? And then when we get these 2 points, then the solution is that x is greater than this point and is less than that point. So these are the steps involved to solve quadratic inequality in general. Correct? Now you know x squared equals to 9 means x is equals to, let's square root it, plus minus square root of 9, which is plus minus 3. Or plus minus 3, correct? So that means these points are minus 3 and plus 3, correct? And that means the solution is x is greater than minus 3 and is less than plus 3. So that is the solution for us. Do you understand now? So we can write down the answer, and that is x belongs to real numbers, so that x is between minus 3 and plus 3. So that is how we are going to solve these questions. So the steps are, first, solve the equation first, and then figure out what part is the solution set, right? So whenever it is less than, it is in between those 2 points, right? Now let's look into the next example where it is x squared greater than equal to 1, and let's see how it changes. So let me again sketch a parabola like we did last time. So we have x and y coordinates. While in these inequalities, it's not very necessary to show y-axis, right? We can actually work with just x-axis. It's easier to explain and do the question, right? Now let's say this is our graph of x squared. So this is x squared for us, okay? Now we want x squared should be greater than 9. In this case, x squared should be greater than 1. That means let me draw a line which is y equals to 1. Now the solution set is beyond this line, right? This part of the graph is our solution. X squared greater than and also equal to, that means it is also part of solution, correct? So on a number line or on x-axis, you can drop the projections, and you know the x values we are looking for are beyond these points towards infinity. So that is the solution. Do you understand? So basically in this case, what are we going to do? 2 steps. First, we are going to solve for x squared equals to 1, and then we will write down solution that x is less than this value, right? And equal to, since there is equal to sign, and the other one is that x is greater than equal to that point, correct? Now x squared equals to 1 really means x is equals to plus minus square root of 1, that is, it is equals to plus and minus 1. So these points are -1 and +1. So we have a solution here that x is less than 1 or x is less than -1 and x is greater than equal to +1, right? So that is the condition, and we can write in the set form that x belongs to real numbers so that x is less than -1 and greater than 1. It is kind of important to note that when we have quadratic inequalities with greater than equal to sign, then we're looking for outward solutions, right? Going away from the 2 points where the 2 graphs intersect, the line and the parabola. But when we are doing less than, in that case our solution is actually the set in between the 2 points. Do you understand? So that is how we have to see it. So in this case the solution was in between because it was less than. You see, between 300. Here it was beyond, correct? Not in between. So that is how we should see quadratic inequalities, and I hope you understand. So we'll do a few more questions. This is a very simple one to give you an idea. Now here we have 2 questions for you to practice. One is x squared greater than equal to 4, and then we have x squared less than 25. Follow the method and get your solution. I hope that'll be interesting. Thank you and all the best.